So now that we know how to find the regression line, or the line of best fits, let's look at that actual equation and interpret some of its values. So you know you're talking about the regression line if you see this kind of weird symbol above the response variable here. So my y, like I said, it's a response variable. It's you input data and you get some kind of response from it based on this other information here. You should know this from algebra. Y equals mx plus b, slope-intercept form. But this is actually called regression form here in stats. M is still the slope, so that's the number being multiplied to your variable. In this case, my variable is the explanatory variable. Slope gives my change in y units per x units. So it's rise over run. And then plus b, same thing as in algebra, it's our intercept. In algebra, we call this our y-intercept, right? Here it's just the intercept. It gives a value of in y units when x is 0. So it's pretty much the same thing, except we're not talking about xy plane. We're talking about something more like this, kind of half of your xy plane. So my intercept is here. It's my starting point of my data. And then the slope is still your rise and run. Now, intercept usually has no value where x is 0, except for when we're talking about maybe finances. You like to know where you start with your interest, how much money you put down first, and then how it progresses and changes and increases or decreases over time. Also, stock values. You may like to know what the stock price started at, and then see it rise and increase. So that's some of the importance of the intercept. Let's look at some examples. A relationship between the house price in thousands of dollars and house size in thousands of square feet are represented by the regression model here. Again, we're talking about a regression model because we've seen this kind of symbol there. And note that we don't use variables, we actually use what do you do? It's not variables as far as letters, the variables as far as what they actually are, the quantitative variables. So you'll see price equals 9.454 size, so instead of like an x, you actually see the variable size minus 3.117. What does the slope of 94.45 mean? So again, we're talking about size, which is in thousands of square feet. So this means what? Here's my response variable, my explanatory variable. What do you think it means? Again, slope. What does slope tell you? If you look at the chart, and I say the slope here was 94, what does that mean? Anybody? So for every time I go up, I'm going over 94. So it's increasing by roughly, this is in what, thousands? So it's increased by roughly 94,454 square feet per thousands of dollars. Does that make sense? For every $1,000 of dollars, or for every 9,400 square feet, you're adding $1,000 to the price. That's what that slope is saying. Your house is 2,000 square feet bigger than your neighbor's house. How much more do you expect it to be worth? So how would you solve that? What'd you get?
It's 188,900.
Did you get 188,904, 908? Yeah, I think that might be a typo. I got 904. What about y'all? Okay. Okay. So yeah, you're going to plug the value into your size, and it's going to give you the price. Is the y-intercept meaningful here? So which of these numbers is my y-intercept? Yeah, the negative 3.117. Is this meaningful? Why or why not? So notice we're talking about here is the value of 3.114 or 7. What does that tell me? What's that? What's that?
That's the lowest price.
It's the lowest price. By lowest, you mean that's when my x is 0? Will we ever want a house with 0 square feet?
No.
No. So it's not really that meaningful. It's telling me my house is worth negative $3. I have to give you $3 for a no house. So really not so meaningful here. And sometimes you're going to run into those scenarios where the y-intercept doesn't tell you too much. Because remember, your data set could actually start here, like so, and we're not really too much interested beyond that, like where the x is 0. Oops. Next, a linear model relating hurricanes' wind speed to their central pressures is here. What does the slope mean in this context? So sometimes you could see it written like this, where you have your response variable equals, here's my slope, explanatory variable, minus the intercept. Sometimes it can be written this way. Notice it's the same thing. That's why in your calculator you had that for option, y equals mx plus b, and you have the other option, y equals b plus mx. It's just how you want to write it. So here's another way you could have written a regression equation. So equals 955.27. This is my what? What? This is my intercept. Minus 0.897 central pressure. And this 0.897 is my slope. Yeah. What does this slope mean? 897 over 1,000. What does that tell you? Here's my explanatory variable. As this increases, what happens to my wind speed? As this increases, my wind speed does what? Decrease. As this decreases, my wind speed does what? Increase. So if anybody knows anything about hurricanes, you know that as you start seeing the pressure decrease, that's bad news. That means the hurricane is gaining strength. So yes, that's what the slope is telling me. As this decreases, this will increase. Does the intercept have a meaningful interpretation? Last time we saw that it doesn't make much sense to have a house with 0 square feet. Does it make sense to have a hurricane with 0 pressure? No, so it doesn't make much sense. 0 pressure is a vacuum. I don't think we can have hurricanes in a vacuum. Hurricane Katrina had a central pressure measured at 920 millibars. What does the regression model predict for the maximum wind speed? And 2, Katrina's actual wind speed was measured at 110 knots. How good is this prediction? So go ahead and use the model to predict the wind speed at 920 millibars. And how close was that to what it actually... Is this a good model? What would you say? Yes, no, so-so. It's okay? Fair? That's what I would say. So did you get 130 knots?
Yes.
Okay. It actually measured it at 110 knots, so I'd say it's about a fair model considering all things. It's off by 20 units, but if you're a meteorologist, you predicted it to be a Cat 4, but it was actually a Cat 2. So it's actually, you would say that this is a bad model. I mean, that's a huge difference between categories. What if you were reversed? What if you predicted a Cat 2 and it was a Cat 4? They wouldn't like that. They would probably try to calculate a different model. But as far as the physics, it's okay, like you said.